interruption, but that recording will make a lot of people happy in the upcoming future. So thank you for that reminder. So Python is going to be increasingly important over time, and it is also a very powerful tool and a really useful way to increase productivity, to write models, etc. And as I'll come back to toward the end of this hour, with some concrete stuff, I think that by having training sessions like this and the geospatial seminars in general that New York State GIS Association provides, I'm really looking forward to having a stronger sense of community and sharing among the users here in New York State, of which there are several hundred serious ArcGIS users in New York, and working together can be extremely productive. In order to work in this world, there's really three things, as I said before, that are essential. One is people need to know, or users need to know the elements of Python itself. Users need to know as well the ArcPy interface, which is a set of code and operations and modules and objects that are compatible with Python, that are written specifically for ArcGIS. And finally, and you'll see this in my example, some proficiency in ArcGIS mapping and geoprocessing itself, using the desktop, as we all have since the beginning, is also part of it. But that's green because, assuming everybody knows that. There are resources available for Python, as I showed last time. Python is a computing language, and it does have standard constructs. It does allow one to create and use variables and values. One important feature of Python is that variables do not need to be declared. And I had some question about this from several people last time. Variables don't need to be declared. You don't have to decide or even know ahead of time what type of data will be stored in the, variable itself. It will automatically create a variable that can hold what you try to put into it, which is extremely useful since some of the data types, data structures that are used in ArcPy are very, very complicated and not really understandable. So values and variables are important. Python, as all languages do, allows one to create definite repetition, meaning an action can be repeated a fixed number of times, such as the standard hello world 5 times. Python also has a while statement, which is common and typical of programming languages, which allow an execution, a repetition, to continue until some condition is met. One feature of Python that's not so common or not commonly used in other programming languages is the ability to easily create and use lists. And in this case, a list containing several text strings has been created and then printed out. And also that list is used in a repetition statement, which one can see right here, which is, annotate. Does this work? Yes, well, I'm just going to make a mess of that. But that, thought I'd try this anyway. So this list also controls, can be controlled by a definite repetition. And we'll see shortly that that's also very useful as well. I'd like to get everybody's head back into the ArcPy world by reviewing 2 of the several scripts that we saw last time. This is a simple script, and I'm not demonstrating its use. I'm just showing you the code to remind you of what a Python script looks like. In this case, it's only a 5-line script, but it's actually fairly useful, and it's an important, what I've found out is called a snippet of Python, a code fragment or a code segment. I believe it's called a snippet. in this environment. And this shows that, I think I'll just use my mouse pointer. This shows that one essential statement in Python programming in the ArcGIS environment is the statement that asks for the ArcPython libraries, objects, modules, and that whole universe of stuff to be actually imported and used. And most Python scripts will have this code in it. Another statement that's very common is an assignment statement, which is represented by this thing that looks like an equal sign, in which a new variable called mxd is assigned an object which represents everything that there is to know and everything there is about the current map document, the current working environment. That's a common Python statement. The next statement in this shows another assignment statement in which we ask a submodule of ArcPython, a sub-submodule of ArcPython called the mapping feature, and inside the mapping feature there's something called list layers, and what this statement accomplishes is all of the layers in the current map document, which we have just been asked to put into a variable called mxd, will be stored in one of these wonderful Python things called a list. And finally, in this script, another powerful method is shown, as well as a useful technique, as something useful and powerful, both. What's visible in, there's my mouse. What's visible in this particular pair of statements here is a repetition in which the Python will be asked to sequence through this list, called list, and print out every element in that list, which is extremely convenient in that one doesn't have to know how many items are in the list or what they are or how they're really stored, except that you just need to use code like this, which will print out all of the layers in that, which are currently loaded in the current map document. One other script that I'll review briefly is this one, and what this one does is, and I won't go into the details, I have more new Python to show you, but what this script does as a reminder is it uses an indefinite repetition, which is implemented using the while statement, and this is an indefinite repetition using the while statement, which allows us to print out all of the values in a particular field of a particular layer. So it's just an illustrative and useful technique that's available in Python in scripting. So this is as far as we got to, and what I didn't mention in this previous script is that not only does this, and it's probably clear from the print statement to most of you, but just to emphasize, this particular structure right here will iterate or repeat through all of the elements in list, which are the layers in the map document, and print out their names. That's what the print statement does. So that's actually a repetition. And for the next example here, we have an indefinite repetition, which will print all of the values in a particular field of a particular layer. Doesn't use them for anything, just prints them out, but it is still a useful illustration of the essence of ArcPython programming. Oh, there was my 9 minutes of review. I promised 8. But that, hopefully at this point, what I'm expecting or hoping is that everybody who's gotten to this point feels a moderate amount of comfort with Python programming and ArcPython, in that you can look at a script and have some idea of what it does and what the meaning of it is, that it doesn't look as if you were reading hieroglyphics of some sort. So, now the new stuff. we'll begin to continue with. So how does one really get started in the practical sense, in reality? I'm a teacher here at the college, and we talk about it being an ivory tower, talk about education and getting an understanding. But now I want to talk about the practicalities. I want to talk about how you all probably will actually begin to create Python code, to create Python tools and scripts to begin to use. Well, one of the most common ways to both learn and begin to develop your own material to use for applications is to study example scripts. And I have on this screen an example script, and I was going to leave Python, or leave the PowerPoint and go to a view screen, which I think I'll do. That's a little bit too small of a font. So I'm going to leave Python. Oh, that's just about as small, isn't it? But now I'm here, so I'll continue with reviewing this script in a Python window. Looking at example scripts, going to Google and typing in example ArcPy scripts or S3 scripts in Python examples or whatever search words you want, will lead you to a fairly large collection and array of things that people have already written, including S3 and their collaborators and cooperators, and it's posted. And it's useful. Load up a script and begin to look at it. And what people tend to do is they try and search on a script that sounds like it does something that might be useful to you or might solve the problem you want. That's a good idea, and it's a good education, and I'll take advantage of this script to teach you a little more, but that is not perhaps the quickest or easiest way to get right to your goal. And I did a lot of this. I've done a lot of this myself. I go and load other people's scripts, look at them, try and understand them, and it turns out it's got features in it I don't understand. It does a bunch of things I don't really care about. So that turns out to be a little bit problematic. It still is useful, and I'd like to use this particular script as an example to teach you a few things and acknowledge that going and getting other people's scripts is a very valid way to learn about Python and find techniques. So I'll go ahead and do that. This particular script, and I think I will use the annotation in this case, this particular script is very nicely written, comes from S3, and I want to highlight this chunk, which in a Python window shows up as red, very conveniently for visual effect. All of these statements begin with pound signs, and you may recall that this is an indication that these are comments. These statements that I've circled with my annotate tool are not executed. They have no function except to explain the program that's to follow. Further down in the second circle, we see a variation, a more elaborate version of the import ArcPy command, which is essential in all scripts because it allows access to the ArcPy libraries. And then we see something here called a try statement, and this is where you come upon something useful, but at the same time you come upon something that might be intimidating or scary when you look at a completed application script that somebody else wrote. And I will use this both to say, yeah, when you go and look at other people's scripts, you'll stumble on things that you don't understand right away. And that's both scary and an opportunity. Right now I'm going to make it an opportunity and just teach you one more little thing. Because I can't help myself, actually, when it comes down to it, I can't help myself trying to teach everybody to be effective programmers. And the try and later in the program accept statements are what are used in Python and ArcPy, of course, for what's called exception handling or error management. And essentially, what this program is set up to do in its broadest structure is to, this is the main part of the program. I'll stop annotating, and that'd be a better way than starting again. This is the main part of the program right here that's circled. That's the actual code that the author of this program wants to execute. But it's possible that for reasons of programming error, for reasons of user error, etc., there might be something that goes wrong while this code is being executed. If that's the case, and a chunk of code, which we're not going to look at right now in its detail, this chunk of code, if there's an error at any point during the execution of this code, then instead of the script just failing miserably and frustrating the user and looking bad, the Python will jump to the segment of the code called the except area. So this is very useful for people who become advanced in their Python scripting and want to make the user experience very friendly and very informative. If something goes wrong, that error is debugged and messages are printed out to the screen explaining the error rather than just having an inglorious collapse of the program. So we learned something from this script. In fact, I learned something from this script a few weeks ago, the try and accept rule. So let's look a little more at this script, and let's see, I'm going to restore. Let's look a little more at this script, and in the means of me, with the goal of me continuing my lesson. So let's look in the try section and see what we see. We see this group of code where it says get parameter. That sounds intriguing. I'm only planning to teach for 60 minutes, so I won't be able to get into this code. But what it does allow is, when properly implemented, with a couple more steps that I don't have time to show you, it allows the Python script to actually get input directly from the user. So if the user wants to run this script with a different layer at different times, that's a useful technique. So I see that, but it's too hard to explain. And let's move on, look a little more at this script. And I'm not teaching as much now as I'm making a point about the process of looking at somebody else's script. Now it says here, for df in data frames, for layer in a particular data frame, and then an if statement. Well, that's stuff that you should be able to recognize and not find too particularly fearful, but it's also a little bit tricky to understand and write. This is obviously repetition with a choice all wrapped up in that nested repetition, which is very slick. And what it's actually doing is it's going through every data frame that's in the current map document, every layer in each of the data frames, and then doing something with each layer. That's pretty sophisticated. But there are times when it becomes hard to find a script that has enough in it. Maybe you're just tired of reading other people's scripts and trying to figure out what the heck they are, and after an hour, 2, 3 hours saying, well, that was really pretty interesting to learn, but it hasn't gotten me any closer to what I actually want to do. Learn stuff, and I appreciate that. So what would you do in that case? What would one do in that case when you, I'm going to go back to my slideshow. Sorry. What would one do as an alternative to downloading other people's scripts and trying to figure them out? Which, as I've just shown you, can be amusing, and educational. But sometimes we don't have time for education. Sometimes one needs to get down to business. There is a way, and this is the best thing I learned while preparing this. The thing I find the most useful and wonderful for myself, and hopefully for you too. Instead of just randomly scouring scripts for ideas, it is actually possible. to have ArcGIS write code snippets for us and actually develop them. And let me show you how that works. Where you begin with the process of creating code snippets in Python that do something that you already know how to do or want to do in Python, the first step is to just go into your geoprocess, just go into a familiar geoprocessing operation. The one I'm going to use for examples as an example in this presentation is one that everybody knows, creating a buffer. So what's visible here is nothing to do with Python at the moment. What's visible on my screen is the dialog box one uses to do a buffering geoprocessing operation. I'll go back to the GIS, Intro GIS 110 or whatever it's numbered for you, where you create a buffer in this case of 100 meters around all the recreation features and save the output as a shapefile in a particular location. So we've all done this, and it's not hard, but what if we wanted this particular operation to be part of some process automation? What if this buffering was one tidbit of a 20-step process in which we would, get a solution, and we want to build that process into Python? So what I have to do is push a button, and all those steps will run through flawlessly with user and all that. How do we turn this buffer operation that we're familiar with and we know how to do, how do we turn this into a Python script? Well, what you need to do first is to actually run the geoprocessing operation that you want to use. One can run that geoprocessing operation that you actually want to use. Once that's okay, excuse me, excuse me for a minute, I just lost myself momentarily. I think I pasted the wrong slide in here. My apologies. It looks fine when I reviewed it this morning. Oh, I know where I was. Okay, I'll annotate this just to make it very, very clear, because it clearly wasn't. Okay, I'll circle it with my arrow. You may not know it. There we go. Back on track. You may not know it, but after you complete a geoprocessing operation, there is something called a results window or object available, and you can access that. Often you'll see a bluish thing pop up in the lower right hand of the screen that says, and hopefully it has a green check mark on it, and those of you who are analysts, regular analysts, will recognize this. A green check mark pops up that tells you your geoprocessing operation worked well. You can access the results through that little window, or if it creeps back out of the screen, you can go to the geoprocessing menu and ask for the results window. And you may not realize it, as I said, but after a geoprocessing operation is complete, a lot of information about that is stored away in the results window. And here's my buffer, so I must have completed the operation. And within that results window, which shows here, once you open the results window through either method, through the geoprocessing menu or by capturing the little green check mark box in the lower right, if you right-click on the tool that you just executed, it's slightly hidden here, it says it's a hammer tool and it says buffer. If you right-click on it, there is a command called copy as Python snippet. And what that command will do is it'll look back at the geoprocessing information that you just executed in the normal way that all analysts are used to, and it will actually put a Python snippet a little tidbit of code in your in the paste memory, that it'll copy it to the paste memory as a Python snippet. So that's extremely convenient. Then what you can do is you can go to your Python script, which you're developing, and paste, because it'll be there ready for you to paste. And that snippet will then become part of the script you're in the process of writing. Let's see what a snippet looks like in the next screen. Well, you know, it's not perfect, because the Python snippet, and I'm not sure if this is due to how I set up my my paste command, but it does tend to lose its carriage returns. But this is what the Python snippet would look like after, if I did save to my scratch pad, the Python snippet to be pasted into my script. This is what it would look like after I put in 2 carriage returns. This is what the snippet will look like. So I needed to know a little bit about Python coding, in that anything that begins with a $ is a comment, which doesn't get executed, and then I needed to realize that the actual statement itself begins with the argpy.buffer analysis. But what I have right here, what I have right here is actual argpy code, an actual functional correct argpython statement, which will do a buffer analysis on a layer called recreation. It will store the result in a temp directory that I picked. It'll have a 100-meter buffer. It will, I forgot now in my buffer analysis what the full means. It'll round the edges of it. And I forgot what the none parameter is. But inside of the, I'll go back a few here. Previous. All of these particular options in the buffer geoprocessing tool, which I didn't pick to use. It says, oh, I won't dissolve. I'll have rounded endpoints and something else. All of the options that could get chosen or end up as defaults will end up in the Python statement that's shown right here. So now I've made that leap, which was kind of a revelation for me, and hopefully will prove to be both useful practically and educational for you all, is the fact that you can go into your, you can be an analyst and say, okay, I need to buffer, then I need to do a clip, and then I need to overlay these, and then do this and that and the other thing. And for each of those steps, which you know how to do as an analyst, you can do it and then say, make a snippet for me, and that snippet becomes our Python code, which then can be inserted into your script, which is truly handy. And it's a way to learn. If you already know the tools that you want to use, the processing operations you want to use, all you have to do is be able to do them, and it'll make code. And now that the code is so nicely laid out, I can actually go in and edit this in my script and say, well, maybe I don't want it to go into a temp directory. Maybe next time I run it, I want it to go into a different directory. I just need to change the code a little bit. So once the code's already written, it's easy to go in and tweak it. Nothing's worse than a blank screen and an empty Python statement you have to fill in. That's intimidating and difficult. But once you have one, you can either use it or use it with modifications. So that's the snippet, and that's probably my highlight of the day. And one should always get the highlights toward the end. I'm only about 2/3 through, but that's a highlight for today. Well, here's another highlight too. Here's another highlight. Python is also compatible with Model Builder, which is a tool that some people swear by and live with, and many people are a little intimidated by or not sure about. And I'd like to assure you that I found Model Builder quite reasonable to learn and to use, at least for relatively simple geoprocessing workflows. And what I've decided to do, rather than show you how I created this particular model that's showing right now, it's actually the same geoprocessing function that I just did. This is, I take the recreation, I buffer it, and come out with, and create a result. It's really quite reasonable to use, and what I'm going to do is right about 12 o'clock, when I end the formal presentation of my slides and stuff, or 10 of or 5 of, wherever it comes out to be, I've lost my clock, I will show a little bit of Model Builder, as well as perhaps answer some questions and do a little chat up until 12:15. So I'll show that later in the presentation. But here's a Model Builder version of buffering all the dots in the recreation layer and creating a new file called buff5. So created Model Builder, which I'll demonstrate. There is, inside of the Model Builder window, by right-clicking on Model and asking for Export to Python script, there's a capability for one to create a Python model, a Model Builder model, and once it works, and you're happy with it, to turn that model into a Python script. And for this particular Python script, it doesn't give you just a snippet. It actually gives a full-bodied, I guess you might say, full-bodied Python script, including comments, which impressed me a lot because, as I said before, I feel this obligation to always try to help people be the best programmers they can be in the most general sense. And commenting, which it does for us automatically, created by a description and a title and everything, that's very good programming practice. So within this particular view here, everything that's shown in red is comment, and the Model Builder exporter is intelligent enough to add a comment and the import ArcPy statement, which is necessary. And it even goes further in the sense that this model script does something that good programmers know, and that is it uses local variables. So rather than just cramming, it's just good programming practice. It makes a program a little clearer to read, easier to modify. It creates a variable which stores the name of the input layer, creates another variable with the name of the output layer, and then in this statement, which looks very similar to the snippet that we created earlier, it will use the variable names. It will use variable names instead of the complete names. It is completely correct and fully functional to take this name in green and actually put it here in the command, and take this name in green and put it here in this command. That would function, but it'd make a much longer buffer analysis statement, and one that's specific. So programming practice says that one uses local variables, one uses constants, so to speak, in order to for the best programming practice. So this export from the model really came out pretty nice, and it actually generated a script that can be now put into our toolbox, and that's another technique that I will not show you today, but I will make that information available on the ArcGIS, the New York State GIS Association website. But it is possible to run a script in a script window, or it's possible to take this and now put it in the Arc toolbox, which makes it completely functional. But anyway, the class today is about actually creating these scripts, and I'll run out of time if I try to do everything. So we've written a script using the Model Builder. I'd like to elaborate and extend a bit upon exporting a model from Model Builder to a Python script. On the ArcGIS Resource Center, once you can navigate through it and find this, there's a script, a blog that was contributed by Dale Honeycutt, who I'm I will be sure to credit, called Considerations when Exporting a Model to a Python Script. In addition to being educational and being a source for the next 3 slides I have to show you, I found this overall blog collection to be very useful in learning more stuff about Python. So I'd like to credit that as well as point you to it. The first thing that I wanted to steal, I shouldn't say steal, I was told not to say steal. First thing I would like to illustrate and credit from Dale's blog is one more example of a model builder script and what it looks like after it's converted to Python, just to show you how well it works and how attractive it is as a way to both learn and to prepare Python scripts. So here's a quick example he provided in which roads are buffered, creating a roads buffer. A study area clips the roads buffer. So the roads are buffered, creating a road buffer. Road buffer is combined using a clip operation with a study area, and we generate a clipped buffered roads layer. Very familiar, very common sequence of analysis. And as promised, here is the code that actually was generated using export to Python, and it's very good. It uses local variables or constants to substitute in, which is very good. It's well commented. Apparently in his development environment, not the Eric Idle development environment, but the one he used, comments come out green instead, but they are designated by a different color always and by the pound signs. Local variables, and then the actual Python commands which do a buffer, and then the clip operation following right out of the buffer. And so this automation, which actually would probably take somebody several minutes to do, a user, to do the buffering and then the clipping and organizing and remembering where all which the files are and what the layers are and what the parameters are, 500 meters and all that, takes several minutes. Now it's a Python script, and even more elaborate Python scripts can be built. And the bigger the job, the bigger the benefit of scripting and process automation. Beware, however, and here's something that I learned from Dale as well, from reading his blog, and this is important. I'm addressing now those of you who are sophisticated enough or intend to be sophisticated enough to build models or workflow automations that have repetition in them. If there needs to be a sequence or a whole bunch of files that get processed, repetition, it needs to be available. In Model Builder, it's called iterate, and that means that a whole group of lake streams and roads are combined in some way. So there's repetition involved in this Model Builder example right here. If somebody like me who wants to write a watershed model, which needs to iterate on a daily basis over a period of 20 years, obviously there's repetition there. The beware is that repetition designed in a Model Builder model does not export successfully to Python. And this is what the non-functional Python code would end up looking like as an export from the previous model I just showed you. It would have something called arcpy.iterate multi-value _MB, which actually doesn't work. This is kind of pseudocode, kind of placeholder code. The export to Python code operation doesn't work for things that involve iteration. So someone who has reached this level of sophistication has to apply their ability to understand Python itself and recognize that this, which is pseudocode, programmers tend to call it that, kind of just descriptive stuff, not real code, that has to be replaced with something that actually does a true repetition. And we can recall that that repetition in Python is controlled by the for statement, and what this says is now there's Python, which says that every item in this list of input data sets then gets clipped. And this is not difficult Python code, but it does show that in order to take full functionality of Python scripting, including iteration, repetition, very sophisticated stuff, you do need to have some knowledge, some experience, or at least an awareness that there has to be a repetition that's actually hand-coded based upon your knowledge of Python. Hopefully, however, at this point, you realize, or you have the feeling that, hey, this right here is not that bad a piece of Python code. It only has a for statement. It says, for an iteration variable, going through a whole list, you do something. So, although you have to do it, and it feels a little scary at first to think hand coding and taking something that came out of Model Builder and you got to go fix it up yourself, it is doable. So that's probably, if you followed what I have said up to this point and have some understanding of it, you're probably as sophisticated as almost any Python geoprocessing automation user out there, and you're the only people in a higher league are probably the ESRI specialists and trainers themselves. So, where are we going to go next with this? Yes, next thing is at that point, some of you are saying, "Wow, this is remarkable," and some of you are saying, "Man, that was a little too much." In either case, I'm going to move on and begin to wrap up the presentation. And what I'd like to, I'm going to make a shameless plug, and perhaps our president of the association, Bruce Oswald, will make a few comments at the end of this too. But I would like to put a plug in myself. These two sessions were sponsored by and organized by New York State GIS Association. Efforts of myself and Bruce and the communications committee to set this all up. New York State GIS Association, again, shamelessly plugging, it is working, and I'm a pretty good judge of the value of something. That's one thing I'm good at, and as I look at this right now, this is very valuable. This is the association and the opportunities it provides, including these. And moving on, one of the opportunities that I am personally taking charge of, because it's a good thing, and as I said, I'm a good judge of what's going to be good, and this is going to be good. Part of the New York State GIS Association website is going to be, and forgive me for getting the terminology wrong, I'm calling it the app site at this moment. It'll be a place where it's going to be sort of sitting next to the resume posting site or section, where people will be able to put up applications and code and such on the New York State GIS Association website. And there will be a place on the NYS GIS webpage where we'll be able to, for everybody who's interested in Python in our group, be able to share scripts and snippets and little tidbits and techniques and, little 4-line or 6-line tidbits that you wrote, and you're pat yourself on the back and share it with everybody else. There will be a place for that. At least for a while, I will, so to speak, moderate it, which means try and organize them and sort them and check them over and stuff and keep it organized. The details for this and the access to this will come through our membership list, as I understand it. So keep an eye for the details. And last slide is my same old thank you slide again. And my email is there. for anybody who'd like to contact me, ask me a question, get in touch. I've had somebody who already asked me about watershed modeling using Python, and that's a thing dearest to me. But I'd be glad to hear from others. I didn't get answers to everybody who's written me in the past few days. I'll work on that this afternoon and tomorrow. But I want to say thank you. And again, here's the New York State GIS Association wrestling with Python, and I think working together we can teach each other, share scripts, and do well in our jobs and careers. So thank you very much, and that's my last slide. So I will close this, and I will actually shut up now. Oh, I'm 10 minutes ahead. I will shut up now and get some any closing comments from Bruce. But I will still be here. I will still be here after between like 11:55 and until I seem to run out of people or just call it quits, to show you how Model Builder works and to answer any chats. There is a chat window. But I thought the best thing to do was just right through the material. Everybody who's happy with it and wants to get a 4-minute break or a head start on lunch, go ahead. But I will turn myself off for a couple minutes until Bruce ends the formal presentation. Then I will come back, show Model Builder, and see if anybody pops up in the chat window. So thank you very much. Some of you will be signing out, and it was a pleasure having you.
Thank you, Jim. It's Bruce. I really appreciate, and the whole association appreciates the amount of time and effort you've made into putting this all together. And I would just say that if people have questions, this would be a good time to pose it in the chat area. And can you see those questions if they come up, Jim?
Make my window bigger. Oh, I do have chats. I do have some chats that I'm going to catch up on. Yeah, I'll review the... Sorry, Bruce, I've been just talking to myself because I turned my microphone off so as not to distract. I do have chats, and I will review them, and as fast as I can get them, I will. So a few things went wrong.
Okay. There is one comment here from Felix Kramer about just questioning, except for learning, if you already work with Model Builder, when would you move to a Python script?
Well, why don't I answer that one, because I actually have an answer for it. And I guess I see some comments here. My apologies to anybody who lost their sound. It looks like that happened to two. But I want to answer that question. Why would somebody, if somebody's already competent with Model Builder, why would you move it to a Python script? Well, it is possible to take the Python script that comes from Model Builder and enhance it to do even more things that Model Builder won't do. The Python script is also a way to, as I understand it, to encapsulate the product and share it more conveniently than Model Builder can be shared. And not everybody and all versions of ArcGIS have access to the Model Builder. So I think that those who don't have access to Model Builder you can distribute the script to them. And for somebody who doesn't want to use Model Builder, doesn't want to learn it, a customer or a client, for instance, it can do that. So I'll save these questions and post a little bit more about advantages to going to Python scripts for somebody who's already a Model Builder user. But that's a very good question. And I also, advantages of using Python over Model Builder, and a favorite Python editor. As far as a Python editor, I got down to the bottom of my list, so I might as well finish. My favorite Python editor is the IDLE editor for using just Python by itself. And then there's also, so if I'm just doing Python coding, not in the GIS environment, I use the IDLE environment, which comes from Windows. And then if I'm inside of ArcMap, there is a Python window in which you can interactively do archive commands. And that editor, you can cut and paste things in and out of it and such. So I enjoy that desktop environment too. And let's see. Good. That would be all the comments at the moment, and I will regroup and get back to the website and to the group with more as I think of good things to say and fill it in. And I'll now mute myself, Bruce. And
okay, well, let's call it a wrap at this point. Thank you very much, Jim. I'd like to thank everybody that we had almost 60 people in on this session today, and we hope to be able to do more. And stay tuned. I think the next thing up will be another lunchtime chat, probably in August, and we'll work from there. So thank you, everybody, and thank you, Jim. It was a great session. Have a good day.